and we are back for the second part of the Chapter 4 lecture. We left off right around slide 27 where we started talking about strings. And so kind of glancing at slide 27, first off, reminder, basics of a string. A string is variable in length, and so the data type string kind of takes up a variable amount of RAM. The more characters in a string, the more RAM it takes up. So there's really not much more to it than that. There are strings with values. So the data type is string. We'll say first name. The identifier is first name. And then inside of double quotes. And so the big thing about string is that they're put inside of double quotes as contrasting to a char, which goes inside single quotes. So a single char, single quote, multiple characters. And of course you can have special characters, and you could have Unicode values and all sorts of funny things inside of strings. As it turns out, C# utilizes what's called Unicode. Unicode is an encoding scheme that supports all the languages of the world. So you think of all those crazy characters out there in other languages that we don't really understand what they mean, but basically all of the letters of all the languages of the world can be put into a string. Strings are double quote. There is something called an empty string. And an empty string is just what it sounds like. It's a string with nothing in it. Now that is a little bit different than null. By the way, in C#, it is valid and basically the same thing with a capital S and a lowercase s. Okay, so in some languages that's actually not the case. In some languages, but this is a nickname, if you will, right? So they have, gosh darn it, I can't think. It's not called a nickname. There's a programming term for it, but it's basically another name for the same. It works the same way. So capital S, lowercase s. It's also worth noting these are different. Empty strings and null is different. Null represents like emptiness, the void, literally nothing, Whereas empty string is technically considered to be something. It's also kind of nothing. So it's basically just realize these two things represent nothing. But sometimes strings hold empty strings, and sometimes they hold null, and those are technically speaking two different values that represent nothing. So at a high level, empty string and null, they basically represent nothing, but they're, from a technical point of view, different. Okay, so sometimes you'll see something like if first name dot, let's see, there's a is null or empty. If string dot is null or empty. There's actually this kind of thing here to see, hey, if first name is null or empty, which tests for these two things, tests for null and it tests for empty. Okay, so this is a method of the string class that can be, kind of used to check for a value before, let's just say you put it into a console.writeLine and then you could even say if it's not empty, writeLine first name. Okay, so let's think about what this is doing. This says, hey, if first name is not null or empty, then print it out. Otherwise, and we haven't covered if-else statements yet, otherwise you could prompt the user for their name. Right, so first name has some info in it, so it should print it out. And there you have it. But if let's just say I print out, what if I test empty string? Empty string, now that prints out, please enter your name. So that's kind of a useful method, and checking against some of the different ways that strings could be without information. Then we start getting into what's called, like if we have ints and we say num1 comma num2, and we say num1 equals 2, and we say num2 equals 3, sure, and we say int result equals num1, num2 plus num1. Okay. We know that the plus operator does addition. Okay? And that's one thing that the plus does. Well, in that regard, if you add strings together, let's add the first name and the last name. Console.writeLine result. We already got a result here, so we'll say full name. And so, this does the same thing. It adds the strings together. They give it a fancy term called concatenation. And this is the result. You get the names run together. And of course, the natural question is, well, what happened to a space? Don't you want a space in between your first and last name? Well, when you do concatenation, there's no space here, right? So if you want a space, well, you got to add it to one of the strings. Either you can add it here in the first name, or you can add it in front of the last name. Now my strings have spaces, and so you can either add the space there, or you can add the space there, and you can get the nice, pretty space in between your name. And this is when you do addition on strings, they call it concatenation, but it does the same thing. It puts them together. There is a useful tool that the book doesn't really talk a lot about, but this could be something you could add to your programs. When you're working with strings, there's a useful tool called String Builder. And if I type this out here, you can see that String Builder is not recognized, but we can we should be able to import it. And so now, using system.text, we add this little statement up at the top, and now String Builder is kind of colored, so it's recognized. So let's call this SB equals new string builder. And then we could say SB dot append. Let's look at append. Append has a bunch of overloads. There's 26 of overloads. It looks like we could take in some different data types. I'm just scrolling through, I'm seeing it takes in all these different data types. And so maybe adding in chars into doubles into strings, adding all these types. Let's just say first name, comma. So the append does not take two strings. It's been a while since I've worked with String Builder. SB dot appends a copy of the specified string to the instance. Here we go. So what we did is we said, okay, we're going to start our string builder, starting it with the first name, and then we're going to append the last name. You might say, well, you know, didn't we just do the same thing as concatenation? We just added these two strings together. Here, we're taking in the first name is our first piece of data into string builder, and we added the last name. But let's do sb.append. Let's just do an integer, right? So now we can add in other data types as well, right? So using string builder, we can build out these strings that'll take in not only strings, but it's basically taking in ints and chars and doubles and floats and all these kinds of things. So it's just a more flexible way of building out your strings. Now, we've been doing this already. We've been building out strings using string.format. Remember, string.format was our way of, and specifically GUIs, right? So let's just review the string.format, and I know that this is even this is coming up in our lecture as well, but just as a jump forward point, since we're talking about string builder, we go to our toolbox. Let's throw in a big button and just review this real quick. So we'll ask a user for their age. Label says, enter your age. And then we have a text box. TXT age. So we got a submit button and an age. We say int age equals convert to int32 txt age.text. So we take whatever they type in the text box, we convert it to an int and store it in an int. Let's have another label real quick and we'll ask them their name. So label age. Property, enter your name. Properties of the text box, text name. String name equals text name.text. String builder, SB equals new string builder. And we'll start it off with the name. SB.append is SB. This is not seemingly all that efficient, and I'm sure there's a faster way to do it. We can add the age, SB.append years old. So exactly, we're building a string with user input, right? We're starting off with the person's name, adding in the word is, the person's age, years old. This is really not that efficient. And we'll throw it in a label. We'll call this label result. Label result. Label result.text equals SB2string. So it takes a string builder, takes it to a string. Start without debugging. Let's do the other one, GUI. But you've been doing this whole time, right? You're like, wait a minute, this doesn't seem all that efficient. So we could just more simply, like I mentioned earlier, let's comment out that. Label result.text equals, remember string.format. This is something that we have been using our placeholders. Much more efficient. 0 is 1 years old, comma, name, comma, age, semicolon. Right? So if you remember string.format, this is much preferable. Get you the same result. There you go. Wanted to introduce String Builder, even though right now it might not seem all that efficient. There are times where I've used it in C# and found it to be useful. So might come back. And while we're introducing strings, I just figured out I'd show you another tool in C# for building strings. All right, bunch of examples of concatenating strings. Sometimes you want to force like a new line in your string, and so let's just throw in a \n. So I'll throw in a \n. So this is called an escape sequence. And I'll say this should be on a second line. Debug, start without debugging. Let's see if it works. There you go. So there are some escape sequences. Probably new line is the most common. To put in a quotation mark, you could do a \quote. So that's another one. Because obviously when you put a quote, like let's just say I wanted to quote somebody here and I wanted to say this is my quote, well, that quotation mark thinks that's the end of the string.format. So quotation marks need a \/ in front of them as well so that they know what's going on. So quote's just one of those characters that's a special character. And there's my quote. Moving forward. This is actually kind of common. When we get to a point that we're saving our data, we're going to be saving data to local files. And so that's kind of common, right? So a lot of times you just don't want to have your data get lost in RAM. You want to persist your data. You want to save your data. And so when you do that, there's a couple of ways that's common to give a file path. Because when you're saving things on a local computer, you know, there's C:\\. You got to give it a path. And that's what we're looking at here that I have highlighted, C:\. But a \/ is also an escape character. So to represent a \, you do it with two \/, right? Just like to represent a quote, it's \quote. To represent a \/ is two \/. This syntax, though, is not easy on the eyes, I guess. It's also just not preferable. It's like, isn't there an easier way than typing in all these double \? I mean, you can imagine some of these paths are kind of long, and to type in two \/ every time, that's kind of annoying. So they make these what are called verbatim string literals. And what you do is you put the @ symbol in front of your string, and then it takes it more literally for the path. And so when you see this @ symbol, it's basically saying like, okay, take the \, literally. Kind of the same thing here. Here with this @ symbol, you know, you can kind of get quotes to result in single quotes, even though this is tick for tat, if you ask me, \/ quote or double quote for a single quote. But that @ symbol basically says take this string a little bit more literally to the compiler, And so, it knows how to work with it. And so you see these. Another way that these are used is white space. And so you can actually space things out a little bit more. I know on the hands-on test, some of you were like, I want to space this over, and I put in a bunch of spaces, and I don't get a bunch of spaces on the output, right? So by using a verbatim string literal, you can get more of that spacing, although there's multiple ways to do that as well. This chart here kind of shows you that for every keyword is lowercase, there is what's called a structure that's a nickname for it. And so your data types, lowercase double and a capital double, basically mean the same thing. Again, that's not the case always in other languages, but if I wanted to, here's what that gives us, okay? Here's the importance of this, okay? To say that a byte and has a structure of byte. Because this is a structure, structures can have methods, okay? In some, let's just look at age. Let's just look at age. We got this age, it's an integer. Now, in some languages, I'm just thinking of Java, okay? Java's kind of a dated language. It's been around since the 90s, and it doesn't get updated very frequently. Okay, so Java, C# was based on Java, but, and C# gets updated frequently. And so when you're just looking at Java versus C#, C# is kind of leaps and bounds more modern than Java. C# has a lot of features that Java just doesn't have. So the creators of Java have not really done a good job of keeping up, whereas Microsoft really has. So one thing in Java, like if I do age dot, remember that what's in these cubes, these are my methods. Well, age is an integer, which means that it stores a number, but because integer is also a structure, basically an int is the same as an int32 structure, what that actually allows us is to have all of these methods. So like in Java, an int can store a number and that's all it can do. But if you look here, remember methods are things that it can do. And so these are all methods, these are all behaviors. Like I can take an int and I can convert it to a string. So I'll say string age string equals, right? In Java, there's no built-in functionality to do that. Okay, so this is the importance of this slide, that our data types are also what are these things called structures. The important thing behind structures is just realize that they have methods. And because they have methods, we can actually do a lot of stuff with our variables. And here's an example of this, right? So if I say, let's just pretend for now I'm asking for money. Okay, and even though we'll call this text age, or it doesn't even matter what the variable is. Let's say label result.text equals age to string. And this is another way of formatting something as currency. Right? So all I'm doing is I'm taking a number and I'm formatting it as currency here. And there you go. So those format specifiers that we learned about, the :C, the :N, all those specifiers, you can also use those same specifiers in basically the letters are the same, inside of a toString, convert any of your data, a double, a float, a bool, whatever, convert it to a string and throw a little format specifier on it. Okay, so this slide, yeah, we got these nicknames, right? Decimal, lowercase decimal, and capital decimal, they're basically the same thing. And the importance in C# is that there's a lot of not only methods, but, and this is, you probably saw, I could do age dot, and remember down here, these are operators and, conversion. So, oh, that's interesting, right? Remember, these are conversions, right? And we learned we're going to talk about that even more, how to convert data types. It's part of the challenge of C# is like, converting data types. There's 19 ways to do it. And just getting comfortable with a couple of ways is really all you can do. But that's a lot of what we're talking about in this chapter. We've talked about it on Friday, and we're going to continue talking about it now. Yeah.
Okay, so can you go back to your program?
Yeah.
The code. Okay, so you had LBL result.text age.toString.
Yep.
So do you need to make age into a string to use the currency
Yep.
property? Okay.
Yep.
You wouldn't be able to do it as an int?
No.
Okay.
No. So this was one way, age.toString currency. Again, it doesn't really make sense to take age and put it into a currency, but that's besides the point. We're just taking a number into a currency.
I gotcha.
The other way that we've already learned is string.format. And here we learned a placeholder 0:C.
Okay.
And that would be age.
But either way, you need to make it a string. You can't.
Either way, it's a string.
Yeah.
Yeah. And if you think about that, of course it's a string, because what character does it have in it?
$sign.
It's got the $sign. When you format something as a currency, it's adding a $sign. Well, that's not a number. It's going to have to be a string. And of course, we got a text property on the left. On the left and the right, the data types have to match. Good question. There's also this concept of what an object is. We're going to dive a lot deeper into classes and objects as this class goes on. I showed you how to use a toString. That's a great tool for converting your data into a string format. Let's see. There's also .parse. Now, let's check this out. So what's this parse method and where does it exist? It says a static method. So let's do an example of the parse method. So a parse is another word for convert. So if I say string age equals int.parse age. Now this doesn't work. Why? No, I had that backwards. Excuse me. Here's what I need to do. Start over. String age equals text age.text. Okay, we've got a string on the left and a string on the right. Int age equals int.parse string age. So the input to the parse method is a string. So the parse method will take a string and convert it to a data type. Just another way of doing a conversion, right? We use the convert.toInt32. So to convert a string to a data type, we've learned two ways. Convert to int32 string and data type dot parse string. And so I say data type dot parse. Well, int is what we're converting it to dot parse. Multiple ways of doing the same thing. Here's another very useful method, which is TryParse. Yeah.
For the part, if the string has special character, it would do it, right?
Yeah, great question. So let's try. This is a beautiful segue. It's like you read the book and you know what's coming. So let's enter a special character. It's a 3223 pound crash, because you can't convert the pound symbol into an int, right? And it says input string was not in a correct format. It says it crashed on line 24. Okay, so if I go to line 24, right there. Okay, so what we tried to do is we tried to take something that was not convertible and put it into an int. Okay, introduce TryParse. TryParse solves that problem. So we'll do int age semicolon. int.TryParse. We're going to try to parse our string age. Now there's an interesting variable here called outAge. Now we will get into what this keyword out is. For right now, I'm not going to dive into those details. I promise we will. Okay, for now, just realize you got to put the keyword out there. Okay, and now let's do a label results.text equals age to string. Okay, so we're going to try and parse age, and then we're going to put it to a string. And let's just do 30. It worked. Let's do a $, and notice it gives me a 0 instead. Now, the program didn't crash. That's the key thing there. And so if the parse works, if the conversion works, it puts the data into the variable, as demonstrated here. Okay? If the parse doesn't work, the default, no matter what, is to make that variable 0. And so what you can actually do, you can actually put this in an if statement. And you can say, okay, let's try to parse, and believe it or not, this TryParse, it actually says true or false. It will return a value of true or false. And it says if this is true, and you can do it, then let's go ahead and label result.text equals, age to string. If the conversion didn't work, instead of outputting 0, let's say label result.text is you must give me a numeric age. Right? So this TryParse is actually quite useful, because if I do something like that, I could put 45 and age holds the value correctly. But if I put in something funny, oh, wait a tick, I got to take that out. See that line 37? That's why that didn't work. Let's put in, again, let's give it a good number, 32. We got the right output. Let's give it a special character. Now it says you must give me a numeric age. So that's what TryParse does. TryParse is all about, let's not crash your program because of a conversion. Let's try to parse it, and if the conversion works, let's use it. If it doesn't work, let's do something else instead. So, great question. And did I answer that question?
Yeah.
Sweet. It's a good day. We went through the convert class, and we've seen all of these methods. The one that trips people up is toSingle, because that's your float. They don't have that on here. It's a bunch of examples of, they show the TryParse, and they show concatenation. Here was kind of interesting. This is interesting. We got a string on the left. we've got a string adding into a double. And so what happens is an automatic call to the toString method. So when you add in a string and a double, it automatically calls toString for you. So you don't have to call it yourself. So that's nice. And again, we kind of showed TryParse, I think, pretty well. Converting between data types is something that programmers do on a very, very frequent basis. And so, yeah, there's a lot of different ways of doing the same thing, but I mean, that's a big part of our job. So it's kind of like, look, in English language, I could call you Billy, I could call you Bill. They both communicate the same thing, but, you know, kind of a same message, different delivery. Okay. We really don't have a whole ton of lecture left. I'm going to pause it and we'll take a break. Okay. Back from break, recording. Let's see. Where did we leave off? TryParse, the convert class, all these fun things. TryParse. Amel pulled me aside and said, hey, I noticed that if I leave the employee's salary blank, it crashes my program. Right? I don't want it to crash my program if I leave a field blank. And it's like, well, we're going to learn tools for like providing error messages if a text box is blank, or if a conversion works, then use it. Otherwise, give them an error message. But in the meantime, we just use this TryParse, and if it worked, it put the salary into the variable. If the TryParse didn't work, it just used 0 and then multiplied 0 by the raised and got 0 and 0. So instead of crashing his program with just a couple of lines, you know, we use TryParse instead, and now it just gives them values of 0 output instead of crashing the program. So that's nice. You know, here's a bunch of examples of using the convert to int32, convert to int30, convert to decimal, all this kind of stuff. Convert, I mean, you could even take something to a string, right? You could say subtotal.toString, or you could say convert.toString subtotal. Same difference. When you use toString, you've got all these format specifiers. C for currency adds a $sign and commas. P for percent would take a 0.5 and turn it into 50%. N for number just adds commas. D for digits. Number. F for float, which again you can say I want F3, gives you 3 decimal places. So number adds commas, float or fixed is what I often think, but it's technically float, and is how many decimal points do you want? Let's see if they give an example here. C for currency, P for percent, 2.3%. Number with no decimal places, fixed 3, all just examples of using these format specifiers when you use a toString. So the method is toString, and then passing these different values into toString. String.format, we've been using that for basically since the start of class. So nothing should really be new on that slide. All right. Let's see. Here's an important topic for your labs. I'm gonna delete everything inside my button click here. Okay, so The topic is variable scope. What variable scope is what parts of the program have access to variables and what other parts of the program don't have access to variables. So notice I'm in this button click, and let's just put my name in here. First name equals Evan. Because I've declared the variable, remember the variable declaration is when I give it a data type and an identifier. I've declared the variable inside of this button click. This is said to be local scope, which means local to this method. So this first name variable is only accessible inside of this button click. And so if I had another button over here, maybe it doesn't even matter what the button does necessarily, but let's just say button over here. And let's just say that this is doesn't really matter, we'll just call it the reset. The reset button and btn reset. Again, this is very important for your labs, so zone into this concept. So I've got two button clicks, right? I've got submit button click and I've got a reset button click. I declared a variable here called first name, and so it's local method scope. And so if I were to come into here and say label result.text equals first name, you're going to see that doesn't work. It's known as out of scope. And so the rule of thumb, if you need a piece of data to be accessible across multiple events, button clicks, whatever the events are, remember there's a bunch of events that we could have. Remember, if I go to the properties here and I click on events, I mean these are all the events for a text box. Right? So there's a bunch of events. If you need a piece of data accessible across multiple events, well then you just make it scope, you take it out of the local scope and you change it to class scope. Class scope, now notice I'm declaring my first name basically is inside of this class. The class is called form1. Now I can use first name in both of these. I could here if I say first name, I'll reassign it equal to text name.text, whatever, right? The point is first name is now accessible to this method and it's accessible to this method. So scope will get more complicated than this, right? But not right now. For right now, we've got local scope and we've got class scope. Local scope is within a method. Class scope is basically at the class level. Whenever you declare the class, that's when you can declare class scoped variables. And then those variables are accessible across multiple events, basically all throughout this file. Again, it does get more complicated than that when we start getting into what are called access modifiers. It gets much more complicated than that. But for right now, local scope versus class scope. And it even is a little bit more if first name is empty, we would say int age equals 23. Notice I'm declaring a variable inside of a block of code. That variable is not accessible outside. Right? Because we've declared this variable inside of a block of code, it's also local to that block. So this is also an example of a local variable that's local to local to that block of code. Same thing. If you declare a variable inside of an event, it's local to that event. If you declare it inside the class, then you can use it basically in that block of code. So wherever you declare it, you can use it inside of that block of code. That's the rule of thumb. We will use this thing called enumerations. Okay, textbook definition of enumeration. Enumeration is a group of related constants. So you got some data, multiple pieces of data. They're all related. So related, and they're constant. So a group of related constants could be grouped together in what's called an enumeration. Here's a couple examples. Like here, you've got like these terms. You can create this thing called an enum, and we will use this in this class, to basically say what are the acceptable values for the like this terms of arrangement or whatever you call it. You say terms. You could have a terms of 30 days, 60 days, 90 days. And you could set certain data types on your enums. We will use enums. Here's kind of a programmatic, like how when you have an enum, it's kind of like creating a variable. Like the data type is terms. So check this out. Our data type is terms. We're identifying it as t and setting it equal to the value of 30 days. And there are some programmatic benefits to using enums to make sure that the user only inputs certain values. Like what if the user tried to input 45 days? Well, there are no net 45 days. It's either 30, 60, or 90. And so it's kind of forcing valid input into your program when you use these enums. And so good data input is an important piece to any piece of software. So let's do a quick enum. Do a quick code example of an enum. You create these outside of the class. So if for whatever reason, like you are all students at Rankin, and we say at Rankin you cannot have pink hair, right? We have to have a natural hair color. That's one of the Rankin rules. And so maybe we're collecting hair color when you're signing up for Rankin. We want to know what your hair color is. We want to make sure it's one of the acceptable values. Now, if you're going to take hair color, you could store it in a string, right? But then if we were storing hair color in a string, then any string could be possible. Hair color could be pink. And we really don't want to allow that kind of thing. That's not an acceptable input. But strings, by their nature, kind of take anything into them. Okay, so what we could do is we could say black. It's also kind of, because they're constants, red's not acceptable, right? Blonde and brown. What's that?
Red is a natural hair color.
Did I? Yeah, pink. I was thinking pink. Okay. Red is, of course, a natural hair color. Okay. So now we have this, basically, we have this data type. And this data type is, its identifier, or its type is hair color, and we can assign it one of 4 values. And so when the user clicks the button, I could say, okay, well, Tim has a hair color equals hair color dot black. And now you can actually see that we get some actual IntelliSense, and now these are the acceptable values into that piece of data. Black, brown, red, blonde.
So it's like creating a data type?
It's kind of like creating a data type. Okay. Around data that doesn't change, around constants. I mean, the hair color, the acceptable hair colors are not going to change dynamically while the program is running. So these are useful tools. They're not, when you first see them, you're like, what the heck? Why is this important, or how is this useful? I think with a simple demonstration, you can start to see that instead of storing a string as your hair color, this only allows certain values into the program. If you're not one of these 4 values, have you heard like good data in, good data out, crap data in, crap data out? You've all used software before that's like, you don't want crap data out of the software. You want good data out of the software. Yeah.
So it kind of, the way that would be useful in my head anyway would be like, you put it in like an if else. So it's like if the user entered this and it equals one of the correct things,
Yeah.
then you can like enter school or whatever.
Sure, absolutely. So there's your enumerations. We don't use these right away in class, but I will say that we will in this class use these. So they just kind of expose them to you here. This is a newer feature in C#, one of the later updates within the last, 3-4 years, where you can make nullable data. So normally strings are nullable, and that's totally fine. But this is not. And so to say, okay, the age is null, so by putting a question mark on the data type, on the data type, not on the identifier, come on the data type, now this variable becomes nullable. And so why might you want that? Well, if you were going to reset the user's age, what might you reset it to? You might think, oh, I'm going to reset the user's age to 0. Well, 0 is a valid age. So is 0 the actual age, or is it your reset value? And so maybe then you would think, oh, I could just set it to a negative number and test against it being above 0. And that's true. But if you were going to reset the age, you might just, instead of setting it to a negative number, because then what does that even mean? Your age is -5. What is that? You might instead set a variable equal to null to represent a reset. Like there is no age, right? 0 is different than null. And so there becomes usefulness out of making your variables nullable. That's all that is.
So this is one of the things I was looking at because I kept having issues with the text box. So if I were to code it to where a particular text box didn't have any information that returned null, would it still continue with the rest?
Good question. So let's say you got a text box and the user leaves it empty. Is that null? That's actually an empty string. So that's the first thing to realize, that if a user leaves this blank, remember both null and empty string are essentially nothing, right? But there's a slight difference that an empty string is different than null. And so just the first thing to point out there is that if you ask for a user's name and they don't type it, it's actually equal to equivalent like that. This is an empty string. So if you do text name.text and label result.text equals first name, like, so all I'm doing is I'm reading the first name and then I'm printing it out into the label. If I leave that blank, you don't see it, but it is in fact working. It's taking an empty string and putting it into a label. Whereas let's do this. What if I set, you click here and I say the first name is null, and then I try and print that out. That, well, functionally it's the same thing. I was kind of expecting it to crash, but that's clearly not the case. So I don't know that I answered your question other than pointing out leaving it empty is equivalent to an empty string. I don't even know if there was a question in there. I'm sorry, I don't.
I was just wondering if that was a usable method to get it to basically ignore what's in the text box.
Oh, okay, good. So let's do it on a number then. Let's do it on a number. So age. So let's do int age. Yeah?
Okay.
Age equals, nah, that's still going to crash, I believe, because it can't convert an empty string into an int. An empty string cannot be converted into an int. But as we demonstrated, what we do around that is a TryParse. Int.TryParse, what's in the age.text. So this is our string, out age. And so if the user leaves it blank, it'll at least give us now, I gotta put it in the label. Now if I leave that blank, instead of crashing, it gives a 0. Good question. When there is a nullable type, you can use this has value in value to basically say, hey, you really don't want to use something if it's null. If there's a null value, you don't want to try and output it to the user. So you can use this has value property to determine, okay, if this variable has a value, then let's go ahead and use it and output it and what have you. So has value and value. Really that has value is pretty useful there. And this is another new operator, and I'm going to pause the recording real quick. Okay, so we're back recording. One of the features of this particular PowerPoint is a brand new feature in .NET version 8. And if you're a little familiar, you've probably heard of .NET. We're studying this language called C#. More technically, it is a family of languages. .NET is a family of languages. C# is one of those family of languages. And so these family of languages are put out by Microsoft, and Microsoft releases updates all the time, like I said earlier today. They're pretty good about updating the language. In order to have the latest and greatest library of code to utilize, you need to have all the updates on your computer. And so what I noticed when I paused the recording is I actually need, if I were to take something like this and plop it in my code, I get this error that says, hey, it's not available in 7.3, you got to upgrade to version 8. The way you upgrade to version 8 is through Windows updates. Okay, so I actually, and I will do this, I will update, it's a brand new computer. Not only the required updates though, you got to do the optional Windows updates. Okay, when you do optional Windows updates, you'll see .NET Framework version 8 as something that you can check, and then we'll be able to kind of run back and discuss this feature. But I'll walk my class through doing this update so that you can all make sure that it's updated on your computer so we can use this. So we can't use this right now. The other thing that was on there is kind of like an if-else, and this is something right here. And so this is a nullable age, and so age can actually hold an int or it can hold the value of null. And so if age is null, you probably don't want to use age, and so you could say something like int new age equals, and then you basically use these double question marks to say, okay, if it holds a value, otherwise, what is its default value? Like, what is the default age? I don't know, maybe the default age is 1. So if 23 is null, like this, it would default to the value of 1. But if the user does put in a good age, well then the new age would hold 23 instead. And so these are some of the newer features. Again, probably not necessary to have them in your lab, although they might add some benefit here and there. All right, and like I said, we gotta apply those optional updates on Windows to get the latest and greatest features of the language. All right. The PowerPoint then really just kind of goes through some coding examples in the chapter. I'm not going to walk through all those lines of code, being that I broke them down in more detail already. All right, long lecture. We're going to go ahead and stop the recording here.